Okay, in this video, I want to show the setup that I sometimes use for RANO reads for research projects. So as you can see, what I like to do is to open up, if the study design allows for it, open up all of the time points that are available for the patient in a what is called like a simultaneous reading queue. So no queue actually, simultaneous reading presentation. Um, and I use ITK Snap for these type of things for research because it's handy. Just to give a idea, I can open up all of the co-registered images and I can take measurements using this tool. I can also like zoom in. What I usually do is like I zoom in so that the measurement can be a bit more precise. And then I can also look at the segmentations that we create separately. Now I'm activating and deactivating the visualization of a segmentation. So that's can be done with all time points. So you can get a sense of the images, the measurements, the diameters, and also the volumetric measurements with segmentations all at once, which I think is very helpful when you have to do an overall assessment. Um, just so you know, I also have a separate screen where I have or in this case, six terminal windows open. So just as many terminal windows open as the time points that I have to analyze. In fact, I did launch all of these ITK Snap instances, each one with a different terminal window. The reason is that I can locate the current directory where the data is for that specific time point and then launch the ITK Snap in this way so it will automatically open all of the sequences that I want to look at and the segmentation that I want to look at. And additionally, what I often do is if there are issues in the pre-processing, like the images are not registered well or the segmentation has some issues, and I have to do some modifications through a terminal window, like mathematical operations or re-registration, I can do it very easy because I already have a dedicated terminal window for each time point that I can work on. Okay, so as we saw, so this is the general setup. I forget if I said it already, but of course like open up flare or T2 at least and T1 pre-contrast, and we also have subtraction maps between T1 post-contrast and T1 pre-contrast to get the actual again an actual idea of what the contrast enhancing tissue is. So in this case, we're applying RANO 2.0 for contrast enhancing tumors. So we are only contrast enhancing lesion components can be target lesions. Let's take a look at the overall behavior of this tumor throughout the time points that we have. This is a recurrent tumor. Okay, let's take a look at the baseline image where there is one measurable lesion that we can use as a target lesion. And we can see, well, I will discuss the measurements in a second, but let's just say that this qualifies as a RANO measurable lesion, meaning that it's at least 1 by 1 centimeters in three planes. And then this single measurable lesion remains measurable and of similar size on the follow-up. Of course, these minor areas of contrast enhancement do not meet the criteria for measurable disease, so they cannot be target lesions that we measure and track over time. On the third time point, there is a clear growth of the target lesion, and there's also like this new nodule that we see, or at least this, if we can trace it back to this other small contrast enhancing alteration, well, at least we can say that it grew, but it does not meet criteria for measurable disease, so we don't account for it when we quantify the tumor burden. We only quantify the size of the main measurable lesion. On the fourth time point, the main measurable lesion is not measurable anymore. We can't really see any contrast enhancing tissue that has nodular shape and there is at least 1 by 1 by 1. And also the other satellite alteration, we still kind of see it. It's less conspicuous, it's more faint and smaller, but it doesn't matter because it was non-measurable before and it's still not measurable. On the fifth time point, the situation is pretty much stable with the previously measurable lesion that is not recognizable anymore, and this second satellite lesion that again is not measurable. And then the things change, unfortunately, on the sixth time point where there is a new lesion which is more anterior to the other ones that is definitely measurable according to RANO. And then there is a new nodule periventricular in the frontal lobe that is measurable according to RANO criteria. Whereas the other nodule that was not measurable before, it's still not measurable, even though it's definitely more conspicuous and more apparent and larger, probably. Additionally, there is this alteration, but I did not consider it as a measurable lesion because I find that most of this enhancement is a rim enhancement, linear, and it represents the border of the previous surgical cavity. So, so it should not be accounted for in terms of measurable lesions, in my opinion, because there is no clear nodular contrast enhancing lesion here. Maybe yes, this a little bit of this tissue is tumor, of course, but it doesn't meet the criteria for measurable lesion. Looking back at the baseline, and definitely this is some enhancement that appeared at the border of the previous border of the surgical cavity. This is a recurrent tumor, so the surgical cavity is not immediately before this time point, but it was a while back. This is the baseline at recurrence, let's say. And finally, there are a couple of smaller spots of contrast enhancement, like this one or this one too, but of course they do not meet the criteria for measurable lesions. So ultimately, we have two measurable lesions in this final scan. We can also, as I said, look at the segmentations and check that they correctly represent the tumor, which I already did. And I also made some adjustments. As you can see, part of the contrast enhancement that is segmented is part of the cavity border, and it represents some linear pericavitary contrast enhancement. And the same here, and the same here. And finally, we can also take a look at the segmentation of the final time point. In a separate window, I have an Excel file. I did take screenshots of everything because I like to have things tracked if I want to revisit them in the future. So this first screenshot is an overall view of the appearance of the tumor over time. This is a screenshot with the segmentations in the most relevant slice. This is a zoom in of the bidimensional diameters. And this is a plot of the volumes over time. Now, one important note is that it does look like it grows as we saw, and then it shrank back. And it looks like it shrank back to a volume that is comparable to baseline. But we know from what we saw that while at baseline there is measurable disease, these two time points, so it would be 1, 2, 3, 4, and 5, so time point fourth and fifth, have no measurable disease. And all of these volumetric quantification of the segmentation corresponds to tissue that is either pericavitary, so like at the border of the surgical cavity, or somewhere else, but it does not really constitute measurable disease. So we should not consider this volume. This volume should be considered as if it was zero in terms of measurable tumor burden for that time point. This is the agreement currently for RANO 2.0 that we still have to confirm that there is manually measurable disease before we even look at what the segmentation says in terms of volumes. And this is the corresponding chart for the bidimensional manual diameters that pretty much shows the same thing, stable disease, and then this growth that is transitory, and it shrinks back and then finally grows back at the end. So if we have to actually look at the measurements and the mathematics of it, well, this first part is the volumes over time. I'm going to pass on this part because I think the main important thing from educational standpoint would be the manual diameters. So the lesion is 14 by 10 millimeters, then 14 by 10 again, then 18 by 16. Of course, we have to multiply these two diameters to get the bidimensional size as per RANO 2.0. So before we look at the numbers, I want to give an overview. So this was a measurable lesion that remained stable. So this is a stable disease. And then it grew, and this could be seen as a RANO progression because it grew significantly. We'll talk about numbers in a second and why we can say that it grew significantly. And this could be considered a RANO progression if there is no need for confirmation scans. But in this case, there is need for confirmation scans. In this study, patients were given immunotherapy, which is one of the situations where for RANO 2.0, it is advised to consider using confirmation scans. The use of confirmation scans mean that when a lesion grows, you should wait for the next time point and demonstrate that it grew further in order to confirm that the lesion is actually in progression. But what happens here, as we saw before, is that the lesion shrinks back. So this is what we call PSP or pseudoprogression, which counts as stable disease essentially. And then the lesion is non-measurable and again non-measurable. So this means that the lesion is smaller than the baseline, as we saw from the graphs too. And this is what we can define as a RANO response, PR, partial response. Partial because not all lesions are gone. Some non-target lesions, both in FLAIR and even in contrast-enhanced T1, are still there, but they are not target lesions. So we call this a partial response because a measurable lesion became non-measurable, and it is maintained over 2 scans that are at least 1 month apart, so it is a durable partial response, which is the only possible RANO response. After this response, there is a rebound, unfortunately, and the tumor grows again significantly, even without accounting for the specific measurements. From non-measurable, it became measurable, which means it is a progression. At this point, we don't need a confirmation of progression anymore because we already had a PSP event. If there was no PSP event here, so stable response, and then the lesion grows, we may have to wait for a confirmation of progression if we are still within a timeline that we think that we want to obtain confirmation of progression for. But in this case, after PSP, there is never another instance of preliminary progression that should be confirmed. It's straight away progression after PSP. And this growth is called like a growth compared to nadir after PSP, which is the smallest size after PSP. So in the separate Excel file, we can see how there's a time point, then there's volumes over time, but I want to skip this for a second because I want to focus more. Well, I leave some notes, but I want to focus on how we calculate the bidimensional size by multiplying the 2 diameters. And then we calculate changes from baseline in percentage, which is in this case 0% when it's stable. So it was 140, remain 140. Then it became 288 millimeter square. So it's 105% growth, which is significant growth because it has to be more than 25% bidimensional or more than 40% volumetric. So in this case, it is a progression that, however, we call preliminary progression because we need confirmation of progression. And there is no confirmation because the following scan is not a further growth, but rather a shrinkage. So that's why we call this pseudo progression, as we will see in a moment. This shrinkage is minus infinite. So this is why I wrote down minus 9999 as a symbolic number compared to baseline, because baseline had a measurable disease and now scan 4 and 5 have no measurable disease. So this shrinkage, which is a significant shrinkage, is maintained into time points. So this is a RANO response. And then finally a growth, which is, 600% from baseline, but this doesn't matter, as we're going to see in a second. There are 3 different columns that are all relevant. One important column too is percent change from preliminary progression. when we had this preliminary progression, so the first instance of growth that we have to confirm, we see that there is no additional significant growth in the following time point. Quite the opposite, there is a shrinkage. So this is why it's relevant to flag this number here. After this shrinkage, we call these time points, this value as nadir after pseudoprogression. And now we really have to monitor a growth, not compared to baseline, but compared to nadir after pseudoprogression. This is why there's another column, there is percent change from nadir, and then there is basically no nadir until we hit these non-measurable time points. This is why only here I wrote down plus infinite compared to nadir, because the nadir there's no measurable disease and becomes more than 1,000 millimeters squared. Let's remember that you should also consider neurological and clinical changes and corticosteroids, but let's keep that for a second. So the lesion is stable according to RANO or mRANO. RANO 2.0 for contrast enhancing tumors with request for confirmation scan, which is essentially the same as mRANO. So it's stable disease for the second time point. It's PSP, which counts as stable disease for the third time point because we saw that the lesion shrank back in the following time point. Then it hit a partial response, and then finally progression. If we were to not use the confirmation scans, it would be stable disease and then progression as soon as it grew without waiting for a confirmation scan. And at that point, whatever happens next doesn't really matter because when you're calculating the time to progression, you stop here.